So hello and welcome to our crazy presentation. Crazy, why? Because we have 15 minutes and we have our project to tell you and some 69 slides to show. I hope it will work. A disclaimer, he is French, I am a Spaniard. Our accent is way too strong. I hope you can forgive us for it. So, very quickly, who are we? Yep. My name is Horacio González. I'm a Spaniard living in Brest, France. I am a developer and I work at Citizen Data, and a small startup dealing with data collecting and treatment.
My name is Sebastian. Hello. I'm living in Brest too. I'm a developer at Citizen Data with Horacio in Brittany. So, why this project was born? I don't agree with this definition on Wikipedia. Geeks are not peculiar or otherwise dislikable persons. They often have children. In my case, 5 and 9 years old. They're going to school with old computers. You can find it viruses. Their lack of memory makes swap, swap, and swap again. I don't tell about manual software deployment. It's driving me crazy. At the end, Windows XP hardware failure problem, it hurts me to see my children discovering computers in this condition. So I decided to do something.
The easy solution would be to replace our computers, of course, but replacing them is expensive, and in this economy, schools haven't a lot of money, so it wasn't an option. We need a disruptive idea. We need to find a way to improve the user experience without spending a lot of money. So when Sebastian told me about this project, my first question was, it's a local problem? It's only at his children's school? Well, no, it isn't local. In France, it's a problem in both the public and private school system. There is the same problem in Spain, I know it well, and as far as we know, the same problem exists in most of Europe, at least. Schools are alone in face of their IT infrastructure. They have no IT crowd, no computer guru. They must do everything by themselves, and if they are lucky, there is some teacher who likes technology and likes to put their hands on keyboard and try to make things better. So their IT infrastructure is unadapted, but as you know, sorry. As you know, the law of the instrument, if the only tool you have is a hammer, you are going to pound every problem. So they have an inadapted infrastructure, they try to use it, they suffer it, and our children are discovering informatics with that kind of infrastructure. Sebastian?
What I need? Our solution must address both needs of teachers and children. The approach isn't a text-first approach, but an end-user approach. The infrastructure should be more like Android tablets or Chromebook. Simple and general purpose. Keep the cost under control. Needs to use a maximum of the existing IT infrastructure. In the school of my children, we have a wide gigabit network available. And of course, all must be doable by teachers, even the installation of the system. Our platform must be simple to children too. Would you like to ask a 5-year children to remember a personal login, a personal password to access to internet in a school? No, it doesn't work. They're using simple things, browsing the internet with Chrome or Firefox. They use LibreOffice for simple documents, trying to write, trying to make pictures. And they use already educational software with the teachers. Okay, we can do something with Raspberry Pi and the Linux Terminal Server project. Our solution is fully open, costless. We use the Linux Terminal Server project. It acts as server infrastructure with DHCP, DNS, network, and file server for all the different content in the school. Raspberry Pi is more fun, but thin clients are too expensive too. And I discovered Raspberry Pi last year at the Devox, and I said to me, what can I do with that? And I tried to transform it into a thin client working with LTSP server. The goal is killing the desktop. No desktop, no administration, it's more simple. But I don't remember the pricing. One school, for one school, you have a standard solution, replace all the desktop, and the same solution with a strong server for the needs of a school. The economic are €3,000. It is not negligible.
So why Raspberry Pi? Of course, the first reason is cost. As Sebastian has said, a normal thin client is several €100. It's way too much for a thing that only allows to connect to a server. With Raspberry Pi, we can do the same thing for some €40. It's maybe not dirt cheap, but it's cheap enough. Another good reason is hardware standardization. Deploying software in an heterogeneous platform of all computers, it's a pain. With Raspberry Pi, every Pi is identical. You can make a master, you can clone the memory card, and you have the same setup in every new computer in the school. And that makes me think about another advantage. Plug and play. With Raspberry Pi, you only flash the card, put it into the Pi, switch it on, and everything works. There are no complicated setup. It's quick, it's easy. So that means that everybody can do it. You give a teacher a Pi, a SD card, you explain him how to connect, and it works. There is also ecology. In most schools, they have already an old infrastructure. That means they have keyboards, they have screens, they have mouses. Why are we going to take all that and put it into the trash? It seems more logical to reuse it. With our setup, the P is connected to those old screen, keyboards, and mouses, and it allows us to keep costs low and to reuse all those stuff. So, server-side, what must we do to install all this? In fact, it's rather easy. We begin by installing Edubuntu, a Linux distribution especially made for education. And Edubuntu has another bonus for us. LTSP server is already configured, so we install also the LTSP server to allow Pi to connect. Network configuration, it isn't so complicated. For LTSP server, the default configuration is rather sensible. You don't need to touch it a lot. The only thing to do is for a school that haven't some internet filter or proxy to install those infrastructure server side. To keep things simple, we need a new Pi. When it connects to the server, we need everything to be automatic. We don't need to ask the teacher to configure, to declare the pi in some referential, to make complicated or technical things. With our setup, we have built a small web server, Serverside. Each pi, when it connects the first time, it asks the web server, and the server, it creates a new Linux account on the fly, and for each pi, there is an account. Teacher don't need to do anything technical. It only needs to answer the question, what's the name of this pi? The system is highly scalable. Why? Because LTSP servers are made to be scalable. You can have a cluster that can serve thousands of clients. Most schools have some 20 to 50 computers, so we don't have any problem with scalability. But even if we want to put the system in biggest school, we can do it. It's only needed to have some more computers.
Okay, you are looking how to install the Raspberry Pi. First, you flash the SD card. For flashing the SD card, we have designed a very simple flow. You insert the SD card in the server, a hotplot detection will flash integrally with the DD tooling. Second, the SD card is put on the Pi. The teacher responds only one question: what's the Pi name? The provisioning user add is done. The boot sequence is modified on the Raspbian. It reboots, and the install is ended. And the next boot, the Pi will connect to the LTSP server with the light desktop manager to display X screen of the server. It's easy. This task has been done by everyone. It is the goal.
To keep the experience interesting, we try to collect metrics. Metrics allow us to answer some problem to capacity planner, to failure detector, and to monitor user experience. First, for capacity planning, we need to know when we need to add a new server, more disk space. So having system and network metrics, we can know if the current setup is well sized or if we need to improve it. And we also use those metrics for failure detection. We can detect with something it isn't working good. That's rather easy. And we try also to detect when something is going to failure, like a disk who is going to arrive end of life. And our goal is to provide tools to allow teachers to do this failure detection by themselves. If they can know that the system is going to fail, they can ask us, well, it's going to have a problem. Can you come here? Can you tell us what to do? And at last, we use metrics to monitor user experience. We are going to replace an old setup with a new alternative. We need to know if our setup it responds to the school needs. For that, we need to know if the use they are doing, if the platform is well sized, if the platform responds to the use they are doing. Eco-attitude. In some schools, they have also computers that aren't really too old, that can still be used. My wife is a teacher, and when I spoke with them about this project, she told me, well, it's good, but we aren't going to put all those computers into the trash. Could you make some hybrid setting? Yes, we can. Our solution can also accept to have a mixed setup of Raspberry Pi and all computers. The only need is that those all computers need to boot on network. So the Pi will connect, as Sebastian has explained it, and the all computers will boot on network, and we ask the LTSP server for an image to boot on that image.
But like our project, we have usual problems. Office and internet navigation works very fine, but video streaming use too much network, and you see too lag on video. Crypto is not always your friend, because the communication between the SYN client and the server is integrally encrypted. On the Pi, you have an overhead, a CPU overhead, by using crypto. You can debray it. You are in a private network in a school. Security is not can be disabled. Another problem is recorder depth. A bad configuration of the client, you will have problem for the bandwidth, because 200 bits, 32 bits with recorder depth, too many images are transported on the network, and you must decrease recorder depth for maintain the network capacity. At the end, Flash plugin is your enemy. It is not available on ARM because the browser is executed on local app on the Raspberry Pi. So all seats, but using this technology is unavailable in the school.
So where do we go from here? Well, the project is still young. Our first real deployment in a real school with real students will be next week, or when we will be back from DevOps. So what do we want to do from here? Our first objective is to get some feedback, real feedback from real teacher and real students, feedback from people like you that come here to hear about the project. And our second objective is to get real metrics, to know if our system, if our measure that we have tested at home, if they are available in a real setup. We have still some small development to do, like making browser run on local, like Sebastian has said. And our main challenge is to build a community. If there are only us, we can put the solution in 1, 2, 3 schools. It will be fine for them, but we would like to have more people in the project, to have some help, to have people who want to test the system in other schools, to test if it is adapted for more school levels, more school systems. We are going to build a website when the first deployment will be done, and we are going to release our script and our setup on a GitHub repository or Bitbucket. And then we have some crazy project, like when the school will be running on Pi, we can also use those Pi for other nefarious purposes, like helping teachers to teach students to program with Scratch, with some other tools that you know well. So I still have 1 minute. Oh, sorry, 0 minutes. If you have a quick question, it's the moment. If not, we can speak about it with a coffee now. Thank you very much.
Thank you.